There's nothing like a totalitarian regime to convince people that privacy matters.
Oh, I've been all day at a privacy event actually, and then last week was this big. I don't know how well known it is in the US, but this big kind of hacker camp in Germany called Chaos Communication Congress. I was there last week, so I've got a big dose of pro privacy stuff for the past week or so. So yeah. Anyway, now let's talk deep learning.
Sure. Yeah.
Cool.
How AI can flush your idea.
Well, I mean, actually, there was actually a very interesting talk. Maybe we can talk about it a bit more in a minute. From one of a very good talk from one of the talkers about fooling machine learning algorithms. Which was quite interesting, actually. I never even thought about that kind of thing. Yeah.
Oh yeah. Yeah, there's some really interesting work being done there. And you may have heard of a kind of neural network called a generative adversarial network.
Yeah, that's what she was talking about. Yeah. So,
like normally, you have a single feedback loop between a neural net that's trying to learn reality and then what's in reality, right? But with GANs, you construct a double feedback loop, right? Where you have one neural net that's interfacing with reality to kind of try to figure out what's true, like what the true labels are. And then you have a second feedback loop with the counterfeiter, right? It's like between the counterfeiter and the cop, where the counterfeiting neural network gets feedback from the network learning reality about what passes and what doesn't. It's actually a fascinating setup.
Oh, it was really fascinating. The example they showed was I think it's a famous one of trying to make an algorithm think something was a flamingo. A flamingo was a tractor or something. I can't quite remember what the two things were now. I remember the flamingo. I just don't remember the other thing. So, anyway, maybe we should let's get on track. Let's start in quote marks because I think we kind of already have, but with who you are and who Skymind are.
Oh yeah, sure. So I'm the CEO and co-founder of Skymind, which is a 4-year-old company. So we were founded it's kind of 3.5 years old. We were founded in late 2014. And so like, this is the third day of 2018. I should probably get used to saying we're 4 years old. So I was living in a hacker house in San Francisco with my co-founder, Adam Gibson. We hadn't co-founded anything at the time. Kind of just working our day jobs. He was an instructor at a data science institute teaching people machine learning. And I was the head of comms head of communications at a Sequoia-backed startup called Future Advisor. Future Advisor is something they call a robo-advisor or an automated investment manager.
All right.
So in the UK, you have Nutmeg. In the US, we have Wealthfront and Betterment.
Yeah.
And Future Advisor was running number 3 behind those two big ones when it got bought by BlackRock in 2015. So that was my day job. And at night, I was talking with Adam about the startup we would one day create, because he was building some really cool stuff with machine learning. And that was not my background, and I'm not a coder, but I've taught myself enough about it to kind of speak intelligently if people don't ask me too many technical questions. I used to be a journalist.
Okay, yeah. I kind of went the other way around. I used to be a developer, and then I ended up doing well, to be honest with you, journalism is like probably 40 to 50% of what I do, but I make most of my income from doing documentation work and things like that, which is less fun but more lucrative. And actually, it's interesting. I'm looking at the kind of open source components of what you have, and I'm currently doing some work for the company behind Apache Flink, which has a lot to do with Spark. And also I used to work for a big data database that was based around Elasticsearch. So kind of wandered around this field a little bit. But again, I'm not I can code, but not coding at this kind of level. But I'm sort of aware of the systems and how they fit together. But maybe give me an overview of what. Well, actually, as far as I can tell, Skymind is a combination of a few tools. So tell me about what they are and what people can do with them.
Yeah. Well, we integrate with Flink for one thing.
Yeah.
And other message queues and streaming engines, and pseudo streaming engines like Spark. So what do? We have a suite of open source libraries. The most well-known one is Deep Learning for J, because deep learning is just sexy as hell, right? But in fact, the libraries that do the real work are the other libraries we've built around Deep Learning for J. So Deep Learning for J is the place where you configure a neural net. You basically specify the hyperparameters that it will use to try to train itself. But the real work of deep learning, as you probably know, mostly happens in scientific computing, right? It happens just using large matrix multiplications and calculus to calculate differentials and probabilities, right? If you're doing kind of Markov chain stuff. Anyway, all that needs a scientific computing library. Ours is called ND4J, for the numeral. So ND4J it's like NumPy for the JVM, right? In a sense, TensorFlow itself is just a scientific computing library. It's kind of low level. So that's our equivalent. It's for the JVM. But when I say for the JVM, I don't mean it only uses JVM languages. That would be dumb. That would be dumb for us because everybody who's smart about scientific computing uses lower level, faster languages like C and C++. Right. So every single deep learning library that you've heard of, if they're working efficiently at all, they're tapping into those lower level languages, right? So ND4J, but they're not doing it through the JVM, and that's a really interesting thing, right? So you've had this kind of evolution since the 90s when both Java and Python were created, where Python, because it was slower, came to rely more and more quickly on C, right? And you can argue that the most interesting stuff happening in Python is in fact happening in C, right? So what that means is they tapped into better, faster scientific computing tools, right? While at the same time appealing to a crowd that didn't have a computer science degree. So they were offering basically computational tools to mathematicians and scientists in a language that allows you to, quote, code like you think, right? Which has made Python it's given it a really amazing ecosystem for data science, right? So not just NumPy, but I mean, I could throw out some names: Pandas, right? Scikit-learn, Matplotlib. Like Python has a great ecosystem, but Python often falls down when it tries to hook into infrastructure, right? Even if you talk about something like PySpark, they've got network bottlenecks, right? So and another reason why Python sometimes is not the best choice for like really large computationally intensive jobs is because it has trouble with parallelism, right? It was not designed from the ground up to handle concurrent work, unlike Scala, for example. And the aspect of Python responsible for that is called the global interpreter lock, right? The GIL will not let you do that concurrent work efficiently. So anyway, Java and Scala get around that, right? Scala was designed to be concurrent. Java does multi-threading very well, right? And that's why you see a lot of the big data stack, right? Hadoop, Spark, Kafka, Elasticsearch, Cassandra, like all these tools that need to handle and process massive amounts of data quickly. They're written on JVM languages like either Java or Scala, right? Because they can do more work faster.
Yeah.
Right? Yeah. So one of the main questions confronting the machine learning community today is how do I use my wonderful Python tools in a big data environment where I have to tap into these JVM frameworks, right, that do concurrency better. PySpark was one attempt at that. There's a lot of attempts. We're another attempt to bridge create a bridge between the Python ecosystem and the JVM.
Okay. And just to talk use cases a little bit, I mean, under your case study section of the website, you list, and I've seen these listed in under other similar platforms, things like detecting fraud in various ways. Equally, in fact, no, you've got a lot of sort of crime and fraud prevention, and then also commerce and CRM, which is an interesting sort of odd one out in that most of that list. But what would be if you can mention it, who would be some current customers that people might know? Or if not, what are some sort of more concrete use cases that you can mention that people are actually using Skymind for?
Yeah. So you probably saw the France Telecom use case. Mm-hmm. SoftBank is a major customer of ours. The Department of Homeland Security in the U.S.
Right. Yeah, fair enough.
Yeah, and there, there's some I could tell you on this call, but I'd prefer you not to publish.
No, it's probably best you don't. It's fine. So, I think that's enough to get an idea anyway. And I mean, so what do you see yourself offering over other competing libraries or platforms in this space then, to make you attract at least two very large and well-known clients there?
Yeah, sure. Well, I think the place to start talking about it is to ask the question, why do most data science projects fail? Okay. Right. So that's the dirty secret of our industry. Most of them fail for a lot of reasons, some of which are preventable and have technological solutions, and some of which are harder to solve. Mm-hmm. One of the reasons why they fail is because data scientists at best are good at creating an accurate result that gives us some insight into the data. That result gets discussed in a meeting, and then nobody does anything, mm-hmm. right? Or basically it never gets deployed to production. Deploying to production is hard, right? So one of the hardest things that these data scientists have to do is relate to a production stack, right? Which is not their training. It's not something they want to do, and sometimes it's not even something they can do. And when I say relate to that production stack, I mean test their models in production, quickly deploy to production, right? Yeah. As opposed to just like experimenting locally on their laptop with their tools and a toy data set, right? So relating to the production stack is hard. AI infrastructure is hard, right? So we exist, like I said, to build that bridge between a Python, a data science ecosystem, and the JVM big data and production stack. So we give them one-click deployment, right? Press a button, we will deploy your model, right? So that's one wall, one brick wall that a lot of teams run into. If you read some of the posts about like productionizing TensorFlow that a company named Stitch Fix wrote here, you read it and you're just like, oh my God, that was months of work on the part of several engineers, right? And a lot of companies don't, startups don't have the time to do that a lot of the time. Companies may not have the talent to do that, right? And in any case, it's just going to be a huge cost to productionize out of those research tools. So we allow people to do that just one click automatic. Mm-hmm. Another thing that these data scientists have to do, so as you know, neural nets are computationally intensive to train, right? You got to take them from dumb to smart, right? And that means crunching a lot of data, and a lot of data means a lot of compute. And a lot of compute means one of two things. You can either spend a lot of time on it or throw a lot of machines at it. So those when you do parallel machines, you're parallelizing time. So there's a lot of different ways to think about parallelizing those machines, and Spark is one of them, right? So we use Spark as fast ETL, fast data pipeline. Mm-hmm. We're loading data simultaneously on lots of GPUs, but on the GPUs themselves, we're using our scientific computing stuff, not Sparks, which are inefficient, right? To make those GPUs process the data quickly, right? So, and what we do is we give those data scientists a managed Spark cluster, right? If they've got Spark set up and they have GPUs, we can make all that work together when they're doing machine learning.
Okay. And so just you've taken a somewhat sort of familiar path for developer tools in that you offer a community and an enterprise version. Is the community version open source, or is it just for free?
It's not open source. Okay. Or I should say it's open core. Yep. So we're an open core company. The community edition includes closed source parts of the code, mm-hmm. even though the core of that community edition is obviously the open source tools, mm-hmm. whether it's TensorFlow or Keras or PyTorch or Deep Learning for J and R. So yeah, ND4J, that's the scientific computing. That's the workhorse, right? That is, mm-hmm. It's actually applicable far outside deep learning and machine learning, right? Yeah. And if you take it one step beyond that, we actually have some other kind of cool libraries. One is called DataVec. It vectorizes data, it tensorizes data. So it's the ETL part, the data pipeline part of the workflow. So it's, if you've heard of Trifacta, it's like Trifacta's data wrangler, but it works better with binary data.
Okay. And actually, I mean, I looked down this list and there's not, I mean, I think the main advantage for the enterprise version is SLAs, which is not particularly unusual to offer that for a fee. and pretty much I think you limit, you say the model server and workspaces are limited. Is that just in terms of a quantity or their performance, or is it limited in another way?
So for the moment, we're giving people 2 workspaces.
Okay.
They can do an infinite number of experiments in any workspace, but a workspace conceptually is a place to group experiments around one project. Mm-hmm. And then we give them 2 production deployments. So they can basically create 2 AI solutions for themselves or their company.
Okay.
Right? And then we'd like to talk to them about helping them out.
And then the only other aspect is something intriguingly, I might want to dig into a bit more detail about quite what this means. I think I get it. Somatic sensor vision and control integration for robotics, which I think I know what that is, and it sounds quite fascinating. So maybe tell me a bit more about what that is.
Yeah. So the sensor side, one way to think about deep learning is it's machine perception, right? And that means that it works really well with anything out in the world, machines with sensors attached, like so cameras, microphones, movement sensors, any of that, right? It's anything that's kind of digitizing our analog world, bringing those signals back. What deep learning can do is either classify those events, it can cluster those events by similarity, or it can take those events and construct some kind of regression for the future out of it. So machine perception, it's very similar to AlphaGo, right? If you think about how AlphaGo works, they have a convolutional neural net. That's a kind of neural net that's really useful for processing images. And they use that to recognize the state of the Go board, right? But that's not enough if you're to be AlphaGo and to win, right? After you recognize the state, after you have that moment of machine perception, then you need to do something further, which is you need to decide how to act, where to place your next stone, right? So that's control. And control happens through another kind of algorithm that's not deep learning. It's reinforcement learning, right? And reinforcement learning is goal-oriented learning. So it has a different kind of objective function, right? And a different one kind of exploring the world. Because in reinforcement learning, when you're exploring the world and trying to maximize your points, for example, your signal, your response from the world is really sparse, right? Like with deep learning, I can come in with 100,000 images that are all properly labeled, and my signal in a supervised learning context is dense. I know exactly the right answer for every image I want to classify, right? Reinforcement learning is not like that. Just like you and I, as we live our lives, we're in a reinforcement learning situation, right? The problem is that, maybe I am in the process of fucking up right now as I speak, and I won't know it for 10 more years, right? So that's a sparse signal. That's a sparse signal. So reinforcement learning has to deal with these sparse reward signals in a different way, and it does. And they've found ways to do that well in certain controlled environments, like a Go game, where you have perfect information about the consequences of your actions. It's a little harder when you're putting reinforcement learning into robots, which is what we do. Yeah. But if you can tightly define the problem by trying to teach them which button to push, then you can make a physical object succeed at manipulating the world around it, even when it doesn't know everything about the world yet. And so that's what we did for SoftBank. We put machine vision into one of the robots of their portfolio company, and then we coupled that with reinforcement learning, and it succeeded in learning how to push buttons.
Is it one of the robots I might have encountered, or can you not say?
I can say, it's Fetch. So the portfolio is Fetch Robotics.
Okay. No, I think I've only encountered their Peppers and Neos and some of the others. But no, we're not knowing. I don't know. You meet. It's weird at conferences these days. You meet so many robots, and a lot of them look fairly similar. So sometimes remembering which one was which is a challenge. But that's I mean, they're quite deeply involved with some robot companies. So I think that's a very interesting pairing. Yeah. And actually, I interviewed robot consultants here in Berlin a little while back, and they were talking quite a lot about how they managed to get it to recognize things and the differentiation between just saying, pre-programming a bunch of 5 things it recognizes versus it actually learning to recognize things. There's a big difference. And often people's encounters with robots are really actually not that smart. They're just like basically pre-programmed lists. And as soon as you wander off that script, they're lost. And the kind of next generation that's sort of in development now is something quite different and actually does learn over time. It's also interesting because actually I've spoken to a few companies over the past, I won't say over the past year, but certainly over the past year in terms of time span, that are taking a similar approach to what you've taken, but in different fields where there's a complex system that previously was only really handled by developers or tooling set up by developers maybe for other team members to use, be that analytics teams or data science teams or marketing teams or whatever it happens to be. And now I've interviewed quite a few companies attempting to take those systems and add on top some of the features you've got, things like versioning, collaboration, deploying those versions and things like that. And I mean, do you see this as a trend just because now these tools have become more mainstream, or is it just companies have spotted a gap in the market to do this? Do you see any trends in that way?
Yeah. I mean, if I can be frank with you, and actually I've been being frank the whole time, but engineers build things to solve their own problems, right? Yeah. And that's why you have this tremendous glut of tooling startups, right? Yeah. Because that's
for sure.
And so I have to say a lot of those companies are probably going to fail.
Yeah, for sure.
Because engineers are also cheap, and so if they don't price it right, they're not going to make any money. And if they don't kind of align themselves with a business value, right, or business proposition away from just like tooling or this, I'll make your engineers' lives easier. They're just never going to be able to sell to non-technical people or management. Right? So in our case, we're a tooling plus analytics company. And by that, I mean, we produce more accurate predictions, right? Using these algorithms that we hand over to our clients. And those more accurate algorithms move the needle for them in a business sense, right? So if you build more accurate fraud prediction, right, the company can save hundreds of millions of dollars a year. If you build more accurate recommender systems, they can gain hundreds of millions of more dollars per year, right? So we have a pitch where we can sell to non-engineers and convince them that these tools are actually highly valuable. But a lot of the tooling stuff out there, it's more middleware companies kind of grow in the dark.
Okay. But do you see this sort of trend of especially wanting to add versioning to tooling that is quite complex? I guess that's let's rephrase the question. Who are most of the end users of your software? Are they developers? Are they kind of analytics teams, or a bit of everybody? Or who are you aiming this at in the company?
The users are data scientists, data engineers. Yeah. So the data scientists would be the people who tune the algorithms and explore the data. The data engineers would be the ones building the data pipelines.
Okay. Yep.
So data scientists typically Python and R, data engineers typically JVM stack, and then finally the DevOps teams, right? So with AI solutions, you've got a new kind of workload which places big demands on IT resources, and you've got this AI that it's like the new internet, right? Like just like DevOps to figure out how to build robust web servers and make sure the product never fell down. AI is the same way, right? So what we give those DevOps teams is a robust AI model server, right? It doesn't fall down. It's not like a blob of Python and C code in a Docker container, right? That nobody understands. It's well integrated. It's given to them as a jar file, right? It's something that's very comprehensible to these infrastructure teams.
Okay. So what's two questions, kind of the same, but just different time spans. What's been something that you've added or announced recently that you want people to know about, and what's on the roadmap for the next 6 months that you also want the people to know about?
Yeah, sure. Okay, we launched the community edition in November.
Okay.
It was kind of a soft launch, right? Yeah. So it's been kind of in public beta since November. Mm-hmm. We just added Python support in the December update.
Okay.
So we gave people a managed Conda environment where they can use Keras, TensorFlow, scikit-learn, you name it, right? And then what we can do is we can suck trained AI models out of that Conda environment and then deploy them to our model server, right? So for us, that's a big deal. And the reason that's a big deal is because skill works anywhere, right? Like a lot of data scientists will find these solutions only if they commit to a public cloud vendor, right? They could go to Google Cloud tomorrow and find a lot of the things we do, but Google's not going to support them anywhere else, right? And they're not going to help them if they need to be working with their data on-prem, which they often do. I mean, skill itself is really new.
And that's most of what we've spoken about, I think, isn't it? Or pull apart yeah. And you have a nice image here that people can look at to see the bits and pieces and how they fit together. What do you see as the next trends in your space and the spaces that Skymind operates in? Are there anything you see coming up on the horizon that you really want to make sure that you're ready for?
The robotics work we've done is part of a wave that's going to give robots better and better functionality. And what the robots are going to get better at is stuff that you and I take for granted, right? So like that other company you talked to, they'll get better at segmenting images, identifying objects within images, right? And then choosing how to interact with those objects depending on what they are. So they're kind of operating like 3-year-olds now. Maybe we'll get them to operate like 5-year-olds. That's going because they're robots, and meaning because they're an edge device out in the world. They probably need to talk to a centralized brain, right? And that means that there's going to be a lot more streaming data as reality kind of trickles in through their sensors, right? And that means that tools like Flink and others are going to become more important and more necessary, right? For these kind of swarms of robots with this hive mind behind them. And that's true. Like, and by robots, I mean almost any autonomous thing that can move. So that could be cars, that could be drones, right? That could be Roombas, for all I know. Like, they're all just going to be sending updates back to the mothership and getting smarter based on the knowledge of all their peers. I think another place where AI machine learning needs to make a lot of progress is natural language processing. Yeah. Right. Yeah. So you mentioned chatbots; they mostly suck. Yeah. And the reason why they suck is precisely because of this thing we're doing right now. We're inventing sentences, right? Yep. Yeah. Human language is almost infinitely plastic, which is actually a much more complex problem than the real world, because the real world is not infinitely plastic, right? It obeys the laws of physics. We don't have to obey the laws of physics when we tell each other stories, right? Do you know what I mean?
Yeah.
Like magical realism is possible in language, right? Yeah, so that's a greater space of possible worlds that they need to understand, if only to grasp whether something is a lie or the truth or surreal or ironic. Yeah. So that's all hard. And right now, chatbots mostly work on very limited domains. And if you go off, and they can do some machine learning, but they just can't master the space of all conversation states, right? Just too many of them. So for every chatbot maker today, the most important question is how do I recognize that my chatbot's failing so I can hand this conversation to a real human?
Yeah, and it's a fascinating space. I find chatbots and especially voice interfaces interesting because as a writer, studying the linguistic side is quite fascinating. And actually, I picked up some really interesting things on them, that often human languages that are more structured are actually easier for computers to process. And this includes languages like Finnish, where it's probably a fairly low chance of someone making that many chatbots in Finnish. Firstly, because it's a small country, and secondly, because their level of English is so good anyway that, I mean, most people are really happy just to do it in English. But actually, for a computer, it's much easier for it to parse Finnish because the structure is much more expected. Whereas a language like English is wonderfully vague and quite hard to parse. And I've seen some very interesting presentations here, actually. There's quite a good sort of bot making scene in Germany, in English and in German. And Alexa is second language is in German, which I found quite interesting, mostly because Germans are not particularly pro and always listening device more than anything, which is unusual. They decided to do it here second, which is odd, but still. So that's just the way it is. I don't know. I'm going to have to wrap up soon because I'm actually it's evening here, and I'm actually going off to do wonderfully on the subject of what we've been talking about with magical realism. I'm off to actually do a Dungeons & Dragons session. so it seems very appropriate after that.
Respect. Okay.
That subject. Anything we haven't mentioned that you really want to make sure people know? We covered a lot, Chris. If you got any questions for me, I'm available. I'll answer anything you got. Okay.